All right, welcome to Chapter 8, where we will be studying confidence intervals. This is a fairly short chapter, but also a really important one, as this is one of the things that you will actually see quite a bit in anytime you're reading an article that's a scholarly type of an article. And when you're watching polls and things, for example, being an election year, you'll see a lot of polls on TV and they'll be talking about confidence intervals. They won't use that term, but that's exactly what it is that they're talking about. So kind of the big picture here for section 8.1 is we are going to be calculating and interpreting. So we will calculate and interpret an interval of numbers to estimate a parameter. Okay, so we're not just gonna take some data, and we've been estimating parameters anyway, right? That's what we've talked about. Like you go get samples, you get samples of 40 people at a time, you do a whole bunch of samples, and you average them together. That's what we were talking about in chapters 6 and 6 especially, but also a little bit in 7. And so as we get here, what we're going to say is, okay, but we know that that answer, that's not the exact right answer. Okay, just because I go ask 100 people, that doesn't mean that those 100 people are perfectly representing the entire population that it is that you're interested in. And so what we're going to say is, okay, this is what I got, but in reality, I think it's probably between here and here. Okay, that's what a confidence interval is about. So a point estimate is where you start. Okay, a point estimate is the best one number estimate for a parameter. Okay, so it's like the best one number thing you can give for the whole population. Again, remembering that most of the time we can't evaluate or survey or sample the entire, not sample, but survey the entire population. Okay, so it might, hopefully does not come as a surprise. The point estimate for mu, the mean, is going to be x bar, the sample mean. And the point estimate for p, which is the population proportion or percentage, is going to be p hat. Okay, those are the estimates that we will use. And again, that should not come as a shock or as a surprise. That should make sense in terms of what you would expect to find. Okay, so particularly then, what is a confidence interval? Okay, so confidence interval is an interval of numbers centered at the point estimate inside which we are confident the parameter lies. Okay, now it's an interval of numbers. Again, that phrase here, centered at the point estimate. So if you found out, for example, the average height of, a certain tree or whatever was 30 feet, that does not mean every tree of that type is 30 feet tall, but it does mean that our interval is going to be centered at 30 feet. Okay, we might say, we think they range from 28 to 32 feet tall. You wouldn't say 28 to 57 feet tall, okay, because then that's kind of ruling out that whole like 30 feet thing that you found. That wouldn't make much sense. So you are going to be centered at the point estimate. All right, so what does a confidence interval look like? Okay, well, there's two different ways you can write a confidence interval. I definitely have a preference. I like the interval notation better, but you'll also see the inequalities, especially when you get just to different research articles, and also when you're looking in My Open Math, there's kind of a mix of the two because, again, we know you see both. So for a mean, what you do is you use parentheses and you put the lower boundary on the left, then a comma, and the upper boundary on the right. Okay, so for a mean, our point estimate, remember, is x bar. So we would start there and we would subtract ME, which is the margin of error. There's actually a blank down here at the bottom that you can fill that in. It's just a lot easier to write ME than continue to write out margin of error. So you start at the mean, and let's say like with my tree example, the margin of error was 2 feet. So you start at the mean of 30 and you subtract 2 feet. That gets you to 28 feet. That's the number that would be on the left. And then to get to the number at the top, you would add the margin of error. So 30 feet plus, say, 2 feet gets you to 32 feet, and your interval would look like 28, 32. Okay, in inequality form, and you will sometimes see this, especially in my open math, they'll call it a trilinear inequality. It's the same thing, okay? So I just want to point that out in case you see that notation. A trilinear inequality would be the same bottom limit, so your average, take away your margin of error, and then they'll write in between that that's smaller than mu, the actual mean of the population, and that's smaller than the upper boundary, x bar, plus the margin of error. So it just, again, like it would look something like this, 28, 32 when we're talking about heights of trees. Here it would look like this, 28 is less than, mu is less than 32. Okay, so you can kind of make a comparison. For a proportion, it's the same thing, but instead of x bar, we use p hat. So we would do p hat minus the margin of error on the lower end and p hat plus the margin of error on the upper end. And then same thing here, it'd be p hat minus your margin of error is less than p. Our population proportion is less than p hat plus the margin of error. And again, if you wanted an example, let's say we had an estimate came out to be 55% and we had a margin of error of 3%. Well, that would mean on the lower end, 55% minus 3% would be 52%. Adding on that 3% to 55% would be 58%, or in this inequality form, that would be the same thing, okay? All right, we'll stop there and then we'll be heading on to the next page. Hopefully that part at least makes sense.